So first off, I just want to thank all of you for coming. You're all here because you're a valued and appreciated trade partner or supplier. Adrian isn't here right now. He's tied up on another job, but we value you. And we also, the obvious is that the homes don't assemble themselves. So you bring experience and knowledge that I don't have. And what we're trying to accomplish today is explain to you the why. Why do we have the expectations that we do? Most of you, if we're the only builder that's asking you some of these things, it's because we've chosen the performance path with every one of the code cycles that's happened for the past any number of years. And the performance path, which it's not promoted or elevated in the next, it's either the next cycle or the second cycle that we're going to see here. Performance path is going to be elevated to a more equal view than the prescriptive. And code builders follow prescriptive. They don't understand building performance. They don't understand building science. And it's not disparaging. Marnella Homes isn't this elitist builder that knows all. It's just it's the path we've chosen because we've worked with verifiers from day one, and they've shown us ways to exceed code without the expense and without the conflicts between systems by looking at the house as from a holistic approach. And when you don't have systems that are working together, Jacob energy models every single one of our homes. So he tells us, he raises a flag and goes, hey, this isn't working, or we need to improve this or improve that. His third-party verification or inspections when he comes through during construction, he identifies deficiencies very clearly that we can go back to the trade responsible, have them remedy them so that we can move forward in the process. But it's invaluable to us. Most builders don't appreciate the Jacobs of the world because they don't understand it. What I call the points game in Washington, all you got to do is add up points and you pass. And a good friend of mine refers to code builders. Code homes is basically just the bare minimum to get an occupancy. You miss one point or one step and it's illegal to occupy that home. Instead of a performance path where we can set a North Star, however we get there, we still meet it. Well, Jacob's going to walk you through and show you the reason behind it. And the reality is that whether we're the only ones asking you today, down the road, the codes are going to be strengthened, they're going to be more aggressive, and we can either get a hold of it right now as a team and work together and work out the kinks. We want to learn from you. If our schedule has overlap or has discrepancies that aren't allowing you guys to succeed, we need you to communicate to us and say, hey, we get it now, but here's what we recommend you tweaking or doing so that we can all be successful. So you're a part of a team. Many of you know, most builders refer to you guys as subcontractors. We refer to you as trade partners because you're an equal partner to our team of assembly. And so our industry is evolving, whether we want it or not, whether you like it or not, whether you think it's politically motivated, whether you think it's woo-woo, crazy science. Building science is as provable as gravity. And so we can either acknowledge it and be a part of it or be left behind, because you will be left behind if you don't truly understand these things and appreciate why they're part. You may, our fireplace installer has one penetration. He goes, well, what the hell? It's just one penetration in the wall. What does it mean? Or how big of a deal is this? Well, he's got a penetration, and electrician's got a handful of them, and HVAC's got a bunch more of them. And if they're not air sealed to that envelope, you could end up with a beach ball size equivalent hole in the side of your wall, and you might as well just cut a hole and let whatever comes and goes come and go, because they all add up. and the house is a system. And that's what we're going to try and communicate with you. So when we're in all of your scopes of work, all you tradesmen, you have a clause, we call it the own your hole clause. And you're not allowed to cut a hole or penetrate greater than a ½ inch greater than what you need to do. And that's very purposeful, because if it's any smaller, you can't seal it up effectively. If it's too big, then the guys from the insulators are trying to figure out how the hell to clean up this massive hole in the subfloor or whatever. So there's purpose behind everything we ask, and it's not just asking some ridiculous task that another builder just says, we want you to do it because you're working on our homes. We hope when you walk away today, you're going to go, I get it. It makes sense now. And whether other builders are asking for it, when you walk across the curb to one of our homes, this is what we want. And it's what we expect. And what's going to happen down the road is it's not just going to be Marnella Homes. It's going to be ABC Construction. It's going to be these guys, because they're going to start realizing we have to jump on this train or we're going to get left behind. So I can't thank you enough for being here. As I said, you're valued, and the fact that you're willing to take time out of your day to come learn a little bit about why we do what we do. And Jacob and Ramsey have been very gracious. They're with ICS. They're the ones that do our modeling. They're the ones that do our testing. They're the ones that do our third-party verifications. And they're going to kind of walk you through very high level, but hopefully you can all walk away with something tangible that help you, that you can understand that it all makes sense. So again, thank you all for coming. And here's our two presenters, Jacob and Ramsey.
Thanks, Tony. Thanks for that introduction. Starting off here, I want to cover a couple real quick basics. First off, I want to go over the purpose that you're all here today. Is to explain to you what air sealing is really all about, what airflow is in the building. So there's a small aspect of this presentation that is that's educational about air sealing itself, about air barriers, where to seal. We go over those things as well. It's to give you guys an understanding on the importance of air sealing, that it's not just about energy efficiency, really. Air sealing covers more important aspects of construction rather than just simply the energy efficiency of the building. And this really is, and it's an argument. That's what this presentation is we're here to convince you on the importance of air sealing. So hopefully you'll be able to go away from today's presentation with a changed mind towards air sealing if you were against it before. So I guess we'll go ahead and start now. I'm Jacob Hooper. This is Ramsey Beckman. We're the lead QADs at ICS Inspectors. We run our providership. We've got jointly over 20 years of experience in energy consulting specifically. Despite Ramsey's youthful appearance, he's a very experienced person in the field. And now that he's got shaggier hair and a little bit of a 5 o'clock shadow, builders are listening to him.
That's what I tell myself anyways.
First off, I want to address the elephant in the room. Right? People don't necessarily like energy code. Maybe they don't like any codes, don't like oversight by counties or jurisdictions. And the fact is that energy code is here. It's here to stay. It's not going to go anywhere. And air leakage is a part of the energy code. So it's a requirement. And I want to draw your attention also to this lower part of the slide. I found this in the Washington International Residential Code for Washington. That there are 2 areas that cannot be amended by the local jurisdictions. That is the state energy code and provisions of the IBC or IRC affecting accessibility. So it's my opinion that if you're not following the energy code because your local AHJ doesn't require it, you're bringing liability on yourself and the builder. All right, so quickly we want to cover 3 different types of flow that affects a building. We've got airflow, heat transfer, and moisture flow throughout the building. That all affects not just the energy efficiency, but the durability of the home and the quality of the indoor air inside. So today we're talking about airflow. Basics of airflow is in order for airflow to occur, there has to be a pressure difference and there has to be a hole. Air's not going to flow through a solid piece of, it's not going to flow through a solid material. Heat may transfer through that through conduction, but air is not going to be able to carry temperature along with it. Essentially, with like wind washing is what we see occur most often in insulation, where wind washing will actually derate insulation down to like an R0, essentially. If you don't have an air barrier stopping the air from moving past, then your insulation is good for nothing in that area. The heat will carry it through. Again, why air sealing matters. Energy, it affects the energy efficiency of the home, whether you're really on board with the whole argument that energy efficiency matters or not. A tighter house that's ventilated right has a lower energy score, and it's comfortable for homeowners and it's durable. Air leakage carries latent moisture in the air, and it can impregnate the walls with mold and mildew, like we see here. This is a brand new house, not even occupied yet, and we already have the mold in the HVAC faucets because air leakage that's occurring in that area. And then of course the indoor air quality, both against outside contaminants as well as inside contaminants in like the garage, in the crawl space and the attic, is all affected by air leakage. I didn't get it added to this slide, but the figure is, I think I'm going to figure down 96%. I think it's higher than that. 96% of all I guess it was contaminants. 96% of all issues with moisture and contamination inside the house is due to air infiltrating through the walls. That can all be changed by an airtight enclosure and ventilating the system through with controlled ventilation. You want to start now?
So now we're going to do a little breakdown of different components, pinpoint some problem areas, but it is really important that if you want to control unwanted airflow, you first have to identify where is your air barrier in the house and how does it interact with your thermal barrier or your insulation. You want to make sure you install a continuous air barrier, not just in like one direction going horizontally, but how does that transition to, how does the ceiling transition to a wall, and then how does that wall transition to the floor? It's important that it is continuous, and any gaps or seams between different types of material get sealed appropriately. And then if you do have a larger hole, things happen. Sometimes you can't work with the half-inch gap. You get that. You want to make sure that you use a rigid material to span the gap and then seal that thoroughly. And then, as always, you're going to see this a lot. Have somebody on your individual crews that is a designated quality control person. So before they leave the job site for the day, anything that your crews touch, they look over it, make sure that it meets the scope of work. And then he needs some help, test with the blower door, get a qualified verifier out there, and then they can help track down where
we have, we're going to go over quickly kind of like a history, essentially a history of air barrier systems. This is one of the first air barrier systems that we're used to seeing is the polyethylene air vapor barrier installed at the inside of the insulation. We saw lots of problems with doing this, especially once vapor barriers were installed on the outside. You've got two vapor barriers, and then you've got a vapor-locked wall, a lot of mold growing in the area. So we started moving away from that, and a lot of builders, especially in Washington, Oregon State, are using this airtight drywall approach. So we're actually going to spend most of our time today addressing kind of the airtight drywall approach, because this is what you're probably most used to. And Tony's builds use kind of a hybrid with this, and also air sealing the inside the cavity as well. There's the interstitial air barrier. This is all spray foam insulation. Spray foam is itself an air barrier. So if you spray the entire shell with spray foam, you're gonna fully encapsulate that house. Then we're seeing the air infiltration barrier system. This is using house wrap itself as an air barrier, getting it fastened to the side according to specifications, taped, all the seams lapped over 6 inches, taped, etc. The exterior sheathing air barrier. This is actually where we want to go next. This is using your sheathing and as the air barrier and sealing all of that up tightly. I would say this type of air barrier system is much easier to achieve the goal of an airtight enclosure over the airtight drywall approach. And then, I don't have a picture for it here, but there's the insulated sheathing air barrier. This is essentially the same as the last one, except you're sealing it from the continuous insulation on the outside. So we're going to go over these specific components. Not all of these are on these slides, but these are some of the areas that we're really looking at for air sealing details. For floors, air sealing with a slab, to mud seal, the difference between floors, whether it's open to the crawl or a cantilever floor or a garage, floor over a garage, walls. We're looking for air sealing at the sheathing or the weather barrier, rim bands, drywall, air sealing, fenestration, that's windows and doors. Air sealing at both the interior and exterior. Interior walls will, when they're below a vented attic especially, will pull air down behind the drywall. So we're checking to make sure that even interior walls are air sealed from the attic. Air sealing at inside the attic, whether it's vented or unvented, and then some of these other areas, mechanical closets, typically are all pre-rock. The drywall is installed before the rest of the house gets insulated or even air sealed. So this is an area of definite improvement that I think we can easily achieve if we're addressing this. And then the utility chase cavities. Go ahead, Ramsey.
All right, so we're going to start kind of work our way from the bottom up. I know houses start in the design phase, which is great, and we want to make sure we get all these little odds and ends built into people's scopes of work. You could argue air sealing starts at the foundation, but where it really starts coming in is really at the framing, because that's the starting of the shell that leads to the conditioned air. So if we're looking at framed floors, framers are already putting down adhesives to keep the subfloor on top of the joists, right? They want to minimize the squeaking, but one thing is that there's not enough on those seams or areas get mixed. Air can still infiltrate from the crawl space and up through those cracks, even in the seams of the floor sheathing. Here's some pictures. I'm sure you've all seen this at one point in your life. Is that whether it's in your own home or a new construction site, sometimes there's a large gap right underneath the drain for tubs and showers. And this picture on the left, there's actually a tub on one side and then a short wall, and then a a walk-in shower on the other side. So in this case, I actually had to reach my arm in there to grab the picture. So it makes sense that the foam and seal crew wasn't able to do that from the top side that they normally do. This middle picture happened to be a different house, but from up top, it looked like it was sealed really well. But then come down to the blower door stage, they end up failing, and there's a lot of leakage coming in around the bathrooms and even underneath the walls. Well, that's because from up top it looked good, from down below, the gap was so large that there wasn't a full seal over it.
You call this the magic carpet effect. If your lower plate is not getting air sealed, or you have air coming up from through the frame floor, it can actually cause that floor to float. I was in a house that had a vinyl floor in the kitchen, and it was not built to float, but it was waving like this. I wish I could find that video for you guys, but getting those floors really sealed up tightly is going to prevent this, and it will prevent damage to the flooring material as well.
So you guys say you need to glue the seams where they come together?
I highly recommend that. Yep,
Okay.
absolutely.
I don't think that's typical of what I would see out there.
Yeah.
And another thing with that too, some of you may be thinking, well, that was done during a blower door, that's never going to happen in real life. Well, that house was small, so if you turn on the range hood, the clothes dryer, and somebody takes a shower, you're going to still get a similar effect. Another section we're going to move up more so toward cantilevered floors, which this is a big area that a lot of builders are struggling with, is making sure that you align, get the air barriers right so air can't get in to begin with. And what you want to do is install a rigid air barrier, kind of follow that first floor wall straight up. So you're essentially, I guess, cutting off the little overhang and leaving that on its own, but you want to block air that does get into that cantilever. You don't want it to get into the house, between the rim joists, between Venetian levels. So you want to block that stuff off with rigid sheathing materials and then foam seal the seams around. So here are some examples that we've seen out in the field where, let's picture on your right, they do have sheathing on one side, but as the wall changes directions and now the joists run parallel to the wall, they're missing an air barrier on that side. And then on the left, if there's I-joist construction, typically it's hard to get those areas sealed because there's, it's not exactly a straight line. Some framers will actually notch out the little joists so they fit better, and then somebody can go in afterwards and seal the perimeter of that rim joist pattern.
Let me take a moment and just point out the insulation here. There's no blocking, right? But there's still insulation here. Why does this not work to stop the air? Can anyone?
So this would install.
Yeah, it's permeable.
All right. Yeah. So insulation's permeable. It's not sealed around it. I actually go in quite a few homes that have, that vapor wrapped or craft paper back that's put into rim space, and it gets put in there like that because the vapor barrier does act as an air barrier. But if it's not sealed around that perimeter, there's still air that can get around that. So that's the reason why insulation alone is not going to work.
These are just some more pictures of what we would expect to see out in the field. The top photo where the web joist comes in, and even where the web truss or web joist goes through it, even all those little seams and gaps get sealed in. So this is kind of the same concept, but imagine a two-story house where the first level floor is wider and butts out further than the second floor. There's still, in some cases, a gap or an opening to the floor joist area from the attic in between the both conditioned floors. This same area also needs to be blocked off properly and then air sealed, kind of like the diagram.
We're going to talk about walls next. So we've got, from the outside, we have the exterior sheathing and the house wrap together get used to stop the air that's infiltrating from the elements from the outside. It's essentially, especially when you're using the house wrap, that you're installing it according to the manufacturer's specifications. That includes lapping it over, lapping seams by 6 inches at least, and taping all the seams. Of course, also following the right install guidelines. You don't want the water that gets behind the wall to run down behind the sheathing. What we have here is an example of what we're seeing inside the walls at Marnella Homes right now. Every single cavity is getting picture framed insulation, air sealing. Really great air seal at the bottom plate to the subfloor. Every cavity, or at least all the cavities where the seams come up, is getting a very good continuous bead of caulking or foam. So great job on doing that to the air sealers.
Yeah, just a question on that.
Yes.
So, because on Vixel, we weren't sure exactly how often you wanted it, because sometimes you can't tell where that sheeting matches. So we were boxing every single one on that.
Yeah.
If we go around and just make sure that we're just doing it on the ones where the sheeting is lighting up, that's all that's really necessary, correct?
This is actually a great segue to talk about redundancy. Right? Redundancy, as it pertains to building science and construction, is doing the same thing twice, but for a different purpose. Right? The reason for that is that it's impossible to get construction perfect. So you don't want to rely on that first line of defense to stop all the air and get it in there. You want to build a redundancy. So you're talking about sealing every single box, and which one do we really need? Well, if that first cavity fails to stop the air, and you seal the second one's going to help out as well. All of these holes that go through here, if this first line of defense stopped, failed to stop the insulation from coming through from the top plate, it gets through here, it's going to traverse through this hole and try to get, maybe out through the bottom here, maybe through this next hole. So you build in redundancies to be plan B, plan C, D, E, F, and that's what ultimately will stop the air leakage from here. The airtight drywall approach well, I have another slide, another 3 slides after this that'll go into better detail. But you see, it is getting the top plate sealed to the attic for vented attics around all fenestration, windows, and doors. And you can see this is continuous along the bottom plate. Now this is not just, it's hard to tell here, but this air sealing is not just the plate to the floor. This is the plate to the drywall as well. At the top plate, you're stopping, got some attention to that, there we go. Your air sealing here to stop the air that comes through the attic when the house is under pressure from coming down behind the wall. And when it gets into the wall, it's going to, air follows the path of least resistance. It finds a way you can address the air sealing at one area, and if there's a leak somewhere else in the house, it's just going to move to the next area that it can get to. So this is not the part of the airtight drywall approach, but this is what we're seeing with a lot of builds is air sealing inside the cavity, like you saw in that last slide. So here at the drywall, here at the exterior sheathing connection. And of course that goes all the way around, make sure framing that box. At the rim spaces and the floor, just like I said, you're sealing the plate to the floor, also sealing the plate to the drywall. This plate to the drywall is important because it's going to stop the air that gets into drywall coming out into the room. Again, air sealing the cavity to the bottom plate to the outside. Inside the rim, I almost skipped over this. We want to make sure that the rim spaces are getting sealed as well. And I know this slide's different, but this is essentially we're looking at the same thing. The air sealing really really doesn't stop at the conditioned space. It continues down into the crawl space as well. So we want to make sure that that rim gets sealed in the crawl space as well as inside the conditioned area of the house. Here's a couple examples of an unfortunate situation with stairs. This builder did a great job to make sure that in one case, the drywall came down along the stair wall all the way down. They slid it all the way down. That's a great practice to do, but it didn't get sealed. So the result of that was when the house was under pressure during the blower door test, tons of leakage came up behind this drywall and infiltrated at the stairs. You can see how the stairs are notched. The drywall here is notched out with the risers, and the air then leaked past that drywall there. So getting each of the steps sealed there, or if the drywall can get on the exterior side of the stairs, like in this photo here, making sure that drywall gets sealed all the way around it.
So I know he kind of showed some diagrams talking about how to seal the plates to either the subfloor or to the ceiling. Now I'm going to look at some pictures, really kind of showing what we want to look for or what doesn't look good. So most of the time, again, we've already got sealing the plate to the subfloor. Most people do that very, very well. But we really want to keep this approach that we're looking at a 6-sided box, and that we want to seal all the seams of the box with the wall. So bottom is the bottom plate, the top is the top plate. You've got your vertical studs, you've got your exterior sheathing, and your drywall. You want to make sure that those seams all get sealed. So what gets missed frequently is sealing the sheathing to the bottom plate, and this is easiest done at the framing stage. This would be one way to do it, or visually There's another picture. There's another picture that maybe didn't make it there, where they're using tape to tape the sheathing to the foundation wall. That'd be another way to stop the air from getting in underneath the siding.
When you're using this approach here and you're taking a gasket over the ring space like this, it works. This is going to stop the air that's coming out underneath the plate, but sorry, I'm second guessing myself. That is a great part of continuously learning. You know what? I'm not going to confuse you guys any further. Right. Wall plates. So we talked a little bit already about sealing the attic. What you're seeing here is commonly referred to as blackout sealing. This happens before blow-in insulation in the attic. Someone goes in there with a can of spray foam and a headlamp or a light, and they turn their headlamp into red light mode so they can actually see, but they can see all the daylight or light from the room below it, and they go through that with that spray can and with that spray foam and foam up every penetration that they can see. A lot of times, what I see when I'm reviewing someone's air sealing details, I'm sure no one in this room does it, but the penetration gets sealed from one side where it's expected that someone else is going to look it over. But we don't just look from one side, we're looking all the way around every single penetration. So make sure if you're in charge of air sealing details, that your air sealing gets around all the way around the can light, the pipes, the ducting, every part of that perimeter gets sealed. Also here, this is a great way to deal with air that's infiltrating from through the attic from the HVAC closets below it. Because HVAC closets get their drywall pre-rocked and the top plate doesn't get addressed, there's air that comes down behind that drywall that adds the air infiltration from the attic. So going up there into the attic and sealing up those seams around the HVAC closet is going to prevent that air from infiltrating there.
Same can be said if you have an upper level shear wall. That's done right at the beginning, and that never seems to get sealed later on. So that can also be done after the fact from there. Forgive me, but does Marnella use the the seal sealer? This is most common, and for us it's the easiest to verify. We want to make sure that it's installed properly, right? We want to avoid any overlaps in the materials. We don't want to round the corners. Drywallers will always cut that or rip it off, so it's easier for them to install the sheetrock. But then, what happens when you've got a difference of height in your sealants? What should be the correction in this photo?
Still up that knee wall right next to it.
You'll take your seal sealer onto the face of the studs and then run it vertically to meet the upper.
Yeah, I want to propose also an alternative to using the seal here. Tony, obviously this is something that you would have to account for in scheduling, but having a day to insulate or to air seal between the attic lid being hung and the wall itself being hung. To once you have the lid up there and the knee walls go around the perimeter and get that whole attic sealed with your construction sealant or caulking. And then that's going to prevent any air from infiltrating from the attic once you've got a complete seal around the perimeter. And then you can come in and hang your wall.
I think the next photo will show that. So this was a Habitat for Humanity house. They scheduled the drywallers out, they hung the lid, and then they did lower door assisted air sealing. And then they actually used, I'm not sure what this product was, but they basically, for lack of better words, they painted or troweled it on the top plate to the ceiling, and they achieved a 1.4 before they even hung the rest of the drywall.
One thing before we get on, so for our HVAC guys in here, one of the things that Jacob's found on a lot of our homes, just kind of back to what he was talking about, making sure that that mechanical closet is being air sealed from both the bottom and the top. Once your air handler gets in and that return duct goes up, getting around to the back side of that, because the cabinet, the air handler is sitting so close to that back wall, being able to get in behind that is virtually impossible. So you can get most of it from the bottom of the cabinet, but to completely seal it off appropriately, you do have to get up in the attic, because he's chased multiple leaks on our houses back to the mechanical closet by not sealing it from the attic. When you walk in the closet, it's like, oh, they've air sealed it off, they did their job. Then you look around the back and you see this, where there's just no way to get a foam gun up in there and actually do it appropriately.
Yeah, HVAC closets really create an issue for air sealing because they get rock before the rest of the house. Unfortunately, it gets installed to those, even if you're air sealing from the back side of the cavity with some spray foam, you still have all those 2x4 studs all the way around that cavity, and you have leakage at every single one of those 2x4s, even when you're sealing at the top plate. So really, the only solution really is to seal it from the attic. That's the best solution. We chase ghosts all the time. And recommend that it gets sealed at the bottom of the HVAC closet because the air is already getting in there. But really, we want a commitment to get that HVAC closet completely sealed from the attic. I like this photo here a lot. This here shows that maybe not everyone understands what we're trying to accomplish when we're asking the top plate to be sealed. In both of these cases, the seal, well, maybe not this one, but in this case here for sure, the seal was put up at the top plate, but you have this small little knee wall to the attic. And the seal is there, the top plate gasket is there to stop the air from getting into the wall, and where it's going to come out through the bottom or come out through the plugs or any other penetrations, and air goes left and right, up and down as well, so it will just follow the path to whatever opening it has to get into the house. Moving this down to here, to this plate, is is actually going to stop that air. This is a different case. This is a new photo that I took yesterday, and this is an area of concern already because this is such a complex design to get this corner air sealed. The best method is just to spray this in with some spray foam, but if you pull that, again, drywall gasket across here and continue to fit it along the top plate, one, it's still infiltrating from here, but there's a second concern that this top plate is not continuous. It's broken up by each of the truss members. So even if this knee wall gets sheathed from the back, there's still going to be air that gets in behind the top plate gasket at each of these truss members. So the best, easiest solution is to move that top plate gasket down to here, and where you continue along here and then up and follow the top plate gasket out.
Can we stop at this picture
Yep,
for a second?
sure.
Because this is a great illustration of exactly what So this illustration isn't a Marnella home, correct?
Correct, yeah.
And so this illustration here is not six-sided framing.
Yep.
This is not six-sided framing. You can kind of see that we did a great job over here with the gentleman's on the ladder. We did some six-sided framing up here. We missed this in the closet. I saw this, Jacob, after you left. I
Yeah.
walked in there and went, oh,
Yeah.
and gasped. So again, this is kind of our ready frame system, Tony, and if you're looking at this, you see how we want to balloon frame that up to the top? And it doesn't matter if it's a 2x4 wall or a 2x6 wall in our plans. We can keep it with a 2x4 because these guys do a great job with their foam. They come in and foam that for us and get us compliant, so we don't have to rechange the design. But we gotta capture this knee wall correctly, because I mean, Top Notch did a wonderful job in the master bathroom on the other side of this picture. It took the guys 4 hours to go around and have to get that right. You know, where we should be able to take care of it in our framing layout. Balloon frame those up to the bottom of the trusses. And I know that takes Tony's trusses or Louis' truss design to have to make it in that inside heel corner. So we have to figure that out, and so we can get some efficiencies there for everybody and clean it up. And I gasped. This way, I was going to talk to Samuel about it, that we hang the sheetrock and that we're going to have to spray foam that from the attic side, get up in the attic and spray foam that.
Should the backside of that have actually just been sheetrock?
No, well, it would have been nice if we took the ceiling all the way up to the bottom of that truss and carried it out to that hallway. That would have been great, but we dropped it at the back of the closet. I remember Louis and I talking about this a while back. I think we should have just taken that framing and gone all the way to the bottom of the trusses. Then before the trusses got rolled, Top Notch could have sheeted that real quick for us on that back side, and we would have had a good chance of getting an air seal right there. Yeah, but for now, the pivot, we'll sheetrock and we'll spray foam the back side. We have adequate access on the back side, and so we'll do it as a pickup item.
There's another thing here that I just want to point out is the redundancy of having your own quality control person on staff. Adrian, you mentioned that we didn't talk about it yesterday, frankly because I missed it while I was doing the on-site inspection. I didn't see this until I was back at home reviewing the photos.
Okay.
And then I made it into the slideshow. But you know, if I missed it, Adrian missed it, you know, having another quality control person on your team is just going to have that redundancy that hopefully someone is going to catch that.
And talk about when you have a failure like that. What does that do for our blower door?
Oh, this can make, well, especially with Tony's goal of one air change or less. This is going to stop that. It's the airflow. Sorry, let me get my thoughts back together. I don't believe that you can get one air change when you have leakage like this in the house.
So all of our other hard work that we did is just garbage.
Correct. Yeah.
That's my point.
Yep.
So a little bit about some airtight fenestration. We want to make sure that we are sealing those rough openings on windows and doors well. Traditionally, a lot of foam and seal companies, they will just shove backer rod into these areas and then move on because that's one of the quickest methods for it. We would actually recommend that if backer rod is used, it's used to fill the gap and then a bead of caulk follows it, so it actually makes a seal.
Yeah, and Tony's homes all do have, I believe you're all doing the backer rod and then foam or foam over the foam board caulking to fill up the rest of the gap there. I do highly recommend using caulking instead of foam around these. There was a time that foam itself wasn't the best air sealer because it was porous. Foam has come a long way from then since then. But one of the issues that we still see with using foam versus caulking is getting a consistent feed. just with the can of spray foam running out, or the installer being as fast as they can, or just the pressure in the can. I see a lot of very wavy lines with spray foam, and I don't see that same thing really occurring with caulking. So.
I know it's a little hard to tell in the photo, but on the left here, we just have a low expansion foam, nice and neat, and goes around the whole perimeter of the rough opening. This one's a little hard to see, but this one is actually missed altogether. And then kind of the same with the doors. And one of the problem areas are sometimes the door heights and the framing don't always quite match up, and you're left with kind of a funky space right above it. A lot of times, insulation crews will just shove fiberglass in there. That's not really creating that air seal. So what I like to do is I like to remove some of the insulation and look behind it. And if there isn't a seal behind there, we'll call it out as something to improve.
We're kind of jumping back to, again, for air sealing in the attic. So we'll move through this real quickly. Just some, this was sealed, but you can see that just the house, like the wire penetrations for this sealed electrical box still leaks air through there. These airtight sealed can lights are maybe not necessarily so airtight. You can see Ramsey's finger right behind there, giving these exhaust fans down into the actual sheetrock and foamed around it. If that's not done, this is going to fail a lower door. This is going to fail a lower door at 3 air changes even. So.
There are some exhaust fans that are coming out now. Primarily it started with retrofit applications, but they actually come with clips that go into the fan housing and actually go on both sides of the drywall. So the fan itself is flush with the ceiling. And this is good not just for air sealing, but then also the airflow of the exhaust fan itself is not pulling in attic air down and around the housing out. If you have a good seal around the housing, you're going to get all that moist air from showers and baths to actually go out to be exhausted out of the home.
We want to talk a little bit about this. This is kind of new to me, honestly. Okay. So, but Ramsey's seeing this, and this is pretty great.
Something that kind of started getting brought to my attention about a year ago is that people were having a lot of air leakage around their crawl space accesses. And when I take off the access and I look, it has good weather stripping all around the perimeter. But then if you look at the joist itself, where the subfloor meets it, there's actually a little joist hanger here. It's like a metal bracket that holds the subfloor up a little bit. So you can actually see a gap between the top of the joist and the subfloor. When we're running the blower door, air will go through that crack and completely bypass the weather stripping.
So on that, would you want that caulked, or what would be the?
That would be my recommendation, is to make sure you clear off the ledge of all dust and debris first, and then up to the caulk.
Okay.
That would be the solution for one of them.
Yes.
You want to cover this? Oh, okay.
I can, sure. Sometimes we want to find that balance between an aesthetic design and the practicality. So if a drop ceiling is part of the design, we want to make sure we really get the air barriers and the air sealing correctly. Here we've got some HVAC going through it and some can lighting, some sprinklers. The most ideal thing to do is to first actually sheetrock at the uppermost level, which would hopefully also be on the same level as the rest of your attic. We want to sheetrock that, get that sealed, and then work on all the mechanicals and the electrical. Here's another picture. This is a builder's first time doing some inverted soffit so that they can get all their ducts in conditioned space. So this was a single-story home, and when they created it, it looks pretty good when it runs parallel to the trusses. But when it runs perpendicular to the trusses, there's actually, they ran it over the top of the bottom cord. So there's a 3.5-inch gap in each of these cavities that is going to let attic air into the inverted soffit. So this was the fix. They got the framer to put a bunch of block in between each of the trusses. They put a sill sealer on the bottom edge of it, and then they also did a short picture frame seal in each of those locations.
Fire sprinklers. Everyone hates fire sprinklers for air leakage because you can't really do anything about them. You can't, or at least that's been the myth or the understanding for the longest time. It's true you can't spray foam the hole that the fire sprinkler head is coming through. It's going to prevent that fire sprinkler from opening up and serving its purpose of putting out the fire. But if you move the air sealing outside of that to where the to the pipe, just outside of that head, with either the box end method, which actually you cover with both of these, would effectively be the box end method here. You cover the fire sprinkler head from the attic, and then you seal all the way around it, and where it's the pipe is coming in as well. You can also seal fire sprinklers within encapsulated houses, all already going to be inside a sealed space. Using drop ceilings or inverted soffits will accomplish that as well, of course. But if you're just if the fire sprinkler is in a vented attic, really the only thing that you can do, other than just like redesigning the truss system, is to build these boxes over top of each fire sprinkler head.
Have you guys noticed the difference between using the rigid foam board box compared to the mineral wool hat? Like, is there any, because mineral wool hats are a little bit easier.
Yeah,
I don't know because it's mineral wool, if it has any leakage to it or anything like that.
I haven't noticed any difference.
Okay.
Really. Yeah, as long as whichever system you're using is getting sealed around the perimeter of it, and where the pipe is going through, it's going to stop the air.
Okay.
So, question for you then, should we have considered the mineral hats on the canvas job, where you guys went in and did the class? I know the client specifically asked that. No?
Yeah, so typically, most of the time when we do try to get ACH on, we do the rigid foam board hats when we're doing our blackout attic. The mineral wool hats are just like way faster to install, to be honest. So that's why I was asking is we'd probably do that, but we'd probably be putting, rigid board hat cover on them just to try to get the air seal anyways with those. So his was more of that for that vapor thing that George was asking for. So I don't really know fully what his purpose he was going for there, but
we had to appease him on that. But the mineral hat, that's interesting.
Yeah.
Especially if it's easier for you.
Yeah, it's probably because all the guys got to do is just slip the side. Yeah, the rigid board boxes, they're cutting 6 pieces of foam and Lego piecing it together. So I'd be interested. I don't know if we've ever done it with the. We use those for can light covers, and mostly like retro homes are trying to tighten up and stuff. So it'd be interesting to see on our end how easier it would be for our guys to just start cutting a slit inside of that, putting it around the pipe, and just sealing that up with foam.
Yeah.
So might try that out on your next one that's got sprinkler lines. Yeah.
Mechanical closets have from what we've been saying, mechanical closets have the most room for improvement outside of fire sprinklers. It's really that, and that's because one, the obvious, it's the obvious penetrations are not getting sealed necessarily all the way around it, as I was mentioning earlier. We we make sure that it gets sealed all the way around it, not just with what we can see. Even the less obvious penetrations, like around the top plate, again, we're seeing that coming down through there. So a couple examples of that. This is what I would consider an obvious penetration. You see the duct, it's going through the attic. It gets sealed around the top here, and you can see it, but like back here, we get back here with a long handled camera, and we can observe it from the back, or we get up into the attic and we observe it from the attic side as well. This duct here is not even sealed at all through the top.
Is your guys' drywall usually up? If I remember wrong, your mechanic, that's all up at the time of wall install, right? So the guys can just get up on the ladder and do it.
Yeah.
Okay.
And it's important too, where the ductwork goes up, that they lift back the insulation and actually seal the rigid metal.
Oh, yeah, where it penetrates.
A lot of companies, they'll just get up there, they say that they're doing it, but then they seal the outer insulation.
The flex.
And that does not do it for us.
It's your guys' time. We're talking about sealing now. I know you've been waiting patiently for to talk about that. Ramsey, this is your
Oh,
slide.
sure. So,
Yeah.
duct leakage can account for 10 to 20% of the energy bill. And then it also, getting away from the energy side of things, looking at the house holistically, if we have a lot of supply side leakage, you're going to pull more air through the return, causing a negative pressure, and that's going to pull air from any holes that are in the garage space, so any VOCs from chemicals and paints that you got out there, or carbon monoxide from your vehicles can get pulled into the home. It can also pull radon gases up through the crawl space and into the home. On the flip side, if you have a lot of return air leakage, you're going to be pressurizing the home, and again, if it's not air sealed properly and people are cooking, taking showers, you're going to start pushing moisture into the walls. So it's important to have good duct sealing all around and have a neutral balance in the home. So some good duct sealing, they always say apply it a nickel thick, right? You don't want to be able to see like it was just lightly painted on.
Yeah, and unfortunately, I don't have any, or maybe I do here. I'm going to skip past what we're actually looking at here and look inside at the metal edges of the duct here. Every supply register needs to be sealed at where it connects to the boot or to the connecting piece with mastic, nickel thick. Every supply register and return register should be sealed at each corner with mastic as well to stop air leak, because the air will leak or through those little through those metal connecting pieces. Besides that, these are not fortunately nothing that I'm running into really with Marnella homes anymore, but maybe for the other work that you guys are doing, these are some commonly missed areas. Plenum connections, a lot of times they get sealed from one side and it's just getting painted on. And if you're doing that anyway, you should, any sort of plenum area is really under high pressure. Any part of your duct system that's under that much pressure, I think it needs to be sealed from both sides. And this is a matter of contention. Is this building leakage or duct leakage? Right here, we seal this off when you do duct testing. We're sealing at the supply grill register to the drywall here. So so with that, is this building leakage or duct leakage?
The drywall gap?
Yeah.
Building.
Building leakage. Well, It's actually both, because we're sealing here, the drywall gets taped, the ducts get taped to the drywall, and when the ducts are under pressure then, now your ducts come down and leak up into the attic. So you're right, it is building leakage, but this building leakage affects your ducts.
Here's an example of a real house that we tested with before and after. So if we just look at the duct leakage to begin with, this home is going for a 3% duct leakage target. And without getting too much into the specifics, the total leakage is just how much leakage is in the duct system on its own. But for a leakage outside, we were just measuring how much leakage in the ducts is going to unconditioned spaces. Ideally, the lower the better in all cases, but before any work was done, the total leakage was at 6.5%. The leakage outside is at 3.9%. So still a failure in both cases. After all the supply registers were removed and those gaps between the drywall and roots were sealed, we had a 55% reduction in the duct leakage for the total leakage, and the leakage outside was a little bit better at 62%. And so then you can see that it passed that. But what did that do to the lower door? And Klaus, let's just focus on the multi-point. It's a little more accurate at this point. Their target is 3 air changes, and yes, failing by 1/100th doesn't mean much, but it's the concept of it that all the penetrations in the home, they're all connected, and where you do something on this side of the home for your, wherever you're responsible for, it can affect something else in the home later on. So this, we had a 7% reduction, and it's kind of 2 birds, 1 stone.
And that's just from duct sealing?
That was just from duct sealing. Yep, nothing else was done. Just sealed the supply routes to the ceiling.
So just a quick little summary and conclusion here. Air sealing really is everyone's responsibility. If you're putting a hole in the air sealed envelope, you want to go back behind and get it sealed back up afterwards. Air sealing is it affects energy efficiency, comfort, and indoor air quality, but really it's a pillar of the durable home. Your home is going to last longer because there's not air leakage within the walls, pushing moisture into the building materials. It addresses some pressure imbalances and duct leakage that can cause some major issues. And it actually it does all start early with the design of the home, and then following through that with testing afterwards to make sure that you're achieving the goals that you set out to achieve. We've got here a few different slides of just some before and after, good and bad examples here. This is garage rim space. They're using I-joist, it's not getting sealed on the side. This, I would say, this is a lot tighter, but this should still have been sealed around with some caulking or spray foam, because even though you can't see the gap in this case, air is still going to get back there behind between the sandwich, right between it. Garage rim on the floor. Earlier on, when we first started with Marnella, I was seeing a lot of this sort of thing. This is a lot of builders actually are still doing this, and this causes issues leaking from the crawl space in behind the drywall, and this gets into the house this way as well. Want to seal this up with a continuous air barrier on the garage rim from the bottom as well as the top. I don't see many skylights going in, but I just wanted to show an example of how skylights should be air sealed. Just the internal walls, the inside walls of the skylight is not enough to seal that up. bats are not an air barrier. Air just leaks past there again. So you want to put up this solid material and seal up all the sides of it. Tony, you were mentioning earlier, if we were going to have some slides showing the six-sided enclosure for your attic walls. And here's that right here. This was designed, this was a very well-designed wall where there's enough space between the trusses and the interior wall for this extra air barrier to get slid in. Then that insulation will go up into here. The air barrier will prevent the wind washing during the temperature through the wall. This one not only does this not have a six-sided enclosure, but a six-sided enclosure is not even going to be effective in this case because they're missing the top plate, continuous top plate. If that's not there, there's nothing to nail it on there. Nail the six-sided enclosure onto. There's nothing for you to seal it to. You need that continuous top plate before you can even put the six-sided enclosure in there. Here's an example of a cantilevered floor. This is more like a future recommendation. I don't see this too much. But the garage roof was hung after the outside was already sheathed and had the weather barrier installed, and this allows that garage to really be completely sealed from the outside. Opposite to that, this cantilevered floor wasn't sealed around the perimeter, so air coming up through here or through vents in the soffit is going to get up into the floor above it. Drop soffits and drop ceilings and inverted soffits need to be fully sealed. We want to see that everything is addressed like a complete part of the building envelope. It's each seam, each piece of material comes up against one another, and it's sealed with a construction sealant. If there's any penetrations that go through it as well, those also need to be sealed.
Fireplaces. This is you guys. So, was this actually from Marnella?
No, that's another building.
But this is something similar to what you guys practice, just as a standard.
We don't do the seams of the pipe.
What's
Not
that?
the seams of the pipe?
No.
No,
But the
but we
collars.
do the
and
penetration part of the fire top.
So, for a lot of people, there's a lot of pushback about sealing flues or flue collars, or even as it goes through a draft stop. And the pushback we get is, it's not, we're not allowed to seal that per the manufacturer's instructions, even though they say you just can't have any combustible materials touching it. You are allowed to use high temp materials to seal around these areas.
So really, what's the point of this, of sitting together today and going over the air sealing here? We've addressed small educational piece about air sealing so that you guys can learn how air flows in the house and how the different methods to seal things up. We talked about the importance of air sealing, that it drives they can drive moisture into the walls, create an unhealthy living situation further on down the line for homeowners. But there's another one that we really haven't covered, and that's that when you follow best practices, you're supporting the builder's goals. So these are some of Marnella's goals that we work with him on. In Oregon, achieving the REACH code. Energy Star Next Gen, Indoor Air Plus certification, Zero Energy Ready. These all require high levels of performance. Air sealing is one of them. NGBS Emerald, that's the highest level of the green program that Tony applies to. That's NGBS is a holistic. It looks at every stage of construction from acquiring the materials through construction to training the homeowners in living in that house and how to operate the equipment, maintaining the property, and the importance of green construction. This is a new program, Wellness Within Your Walls. Wellness Within Your Walls deals with the idea of, what's it called, Tony? The sick building syndrome. Sick building syndrome is a serious concern for homeowners. It's basically you start feeling sick when you're living in your home, and you find when you leave your home, those sort of conditions they go away. So your sickness is coming from your home. There is the reason for that is typically poor ventilation inside their home and contaminants that are in there. Air sealing the home deals with the contaminants that are coming in from the outside of the home, and then and from the garage, crawl space, and attic, like I mentioned earlier. And then the properly ventilating that house is the other piece that deals with sick building syndrome, using materials that low emission materials, non-emitting materials like formaldehydes are not allowed under that program. Marnella's goal is having a target HER score of 41 without solar. That is, let's see here, 59 points above the 2009 energy code when HERS first started. This is about, HERS 60 is about Washington State code. So this is 19 points above that. Or 19 points, more, 19 points better than Washington code. And being able to achieve net positive with solar, as far as air sealing specifically goes, this one air change target can only be achieved when everyone is on board with air sealing the homes. Just on this line, I was reviewing some building scientists that are involved in code writing further on down the line, and he mentioned that the next national code updates is maybe not the next, but it's coming down the line very soon. That they're pushing for one air change. That's the next building envelope air tightness nationally. Keep in mind, we amend our Washington code up to 3 air changes or 4 air changes. So nationally, we're not on the same level as national, but national sets the baseline that all the other states start to follow. And we're still required to achieve the same level of performance. Ultimately, with all of these goals being met, Tony's homes are able to achieve a minimum 30% savings over the target reference home for these programs and for Washington and Oregon state codes. And we want to see that be able to continue. Really, all we have to present today. Cindy, we'll go ahead and open this up for questions.
Maybe my question is, for the ones at ACH, that's what's the expectation of aero seal being used to, right? The aero barrier, or is that?
Well, we're using it now,
we'd like to get to where we're moving our air sealing to the exterior. And Adrian's been, talking to me about that and promoting that. And if we get to the exterior air sealing and that's done right, then we don't have to be doing this aero barrier.
Yeah, in my experience, getting below like a 2 with just without aero seals, I mean, I don't know if we accomplish that. Hopefully this will get us closer and stuff, so I was just kind of curious the expectation to get through on that.
Because we know it can be done. I mean, the passive house guys consistently are able to get it under 1, and they don't use an aero barrier. So it's a matter of events like this where we're communicating or working as a team and we're finding out solutions. And obviously passive house is a whole nother level, and our buyers are not willing to just open budget, which a typical passive house client is. But they have developed procedures that allow them to do that, and they don't feel the need for aero barrier. So it's picking off, we're all rowing in the same direction. We're getting our homes tighter and tighter as a team, and we can start with Jacob's help identifying, okay, hey, you guys are doing great, we've dropped a half or we've dropped 1, let's work on this. Well, so instead of drinking from a fire hose and trying to do everything at one time, I mean, that's how I got into the place I'm at with this level of building. We took one thing at a time, understood it, perfected it, and then we were given something else. Okay, now try this. And next thing we know, we're down the path looking back and go, okay, well, perhaps this isn't that hard. And our warranty has dropped. Our warranty costs and our calls have dropped because the homes are getting better. And so we get everybody working together with the knowledge base that's here. We will develop those techniques, or we start looking at the passive house community and go, okay, how are you guys doing it? Okay, well, let's, like you talked about, which we did up at George's house, we did tape the sheathing to the foundation.
Yep.
That is one of their procedures. They use Sika tape or whatever it is, and that is how they address that aspect of it. And that's just one of however many.
Yep. No, the goal obviously I think is great. I would love to just be able to tote up your air cylinder 1 ACH. So we'll work on trying to get there. So.
Passive level is, just for information, is 0.6 air changes at 50 pascals. So, and I think all passive, in order to get there, I think all passive level homes are really getting air sealed at the exterior. That's definitely the way where we want to go. Any other questions? Yeah.
I saw a bullet point at the beginning about ventilated versus sealed attics. What was that about?
So what I was addressing there is, I can go back real quick, is the different areas that we're looking at when we're doing the air sealing inspection. Right there. And there is a difference between air sealing a sealed attic or a ventilated attic, but again, obviously insulating that. So this was not really something that we were going to cover, like the sealed attics in this presentation here, because we're not really doing it for Marnella homes. But we're knowledgeable on that. And when we address a sealed attic, we come in and consult through every step of the way on that.
Is that referring to like spray foam on the roof, on the underside of the roof?
Yeah, so a sealed attic is literally just, it doesn't have, it's not ventilated to the outside. The ventilation is under the roof. It's not inside of the attic. But you're right, a sealed attic will typically have spray foam up on the roof deck, or I was talking about contaminants. I got called to a job a year and a half ago where a lady down in Trout Lake was having high levels of VOCs inside of her house that she believed was coming from her attic. Her house was fully encapsulated. I was able to get up into the attic, confirm that it was all coming from the insulation that was up there. Sealed attics, or sorry, spray foam if you don't have a mixture right. If you're installing, if the temperatures inside the house aren't right, it doesn't cure as it's supposed to, and it takes longer to cure, and it can continue to emit VOCs inside of the house during that process. In this case, I think the mixture was just completely wrong, and just professionally, because of that experience, I moved away from recommending spray foam on the roof deck. So my new recommendation is, if you're going to do a sealed attic, you're doing it with the board insulation board over the roof deck, and then you seal the roof deck, and then you do like bats or blown in underneath the roof deck to complete that air sealed, that insulated layer. Other questions? All right.
On like the siding part, when you put a rain screen strip, you're actually creating air movement right along the back of the siding on the outside of the house. How does that play into, like, is that paper, the WRD, or is that sealed enough to where it doesn't allow any of that air to go back? Are we moving towards the zip system with tape?
I'm gonna say it depends. There are some smart barriers like HydroGap that have built-in rain screens on them, and then sometimes the backing is self-adhered, so you can just stick it right onto the sheet. It's all about where you put those layers. Some people choose to make their own rain screen. They'll have fern strips, but we want to make sure that that WRB or the sheeting is closer to the interior of the wall, and that's where the sealing happens. The rain screens are really just so that we can drain any water that gets behind the clad.
So if you're doing those strips, is it almost preferred to use the SA, the self-adhered?
I think it certainly makes it easier, and you always want to think about reducing the amount of trips going around the house. Some people are like, yeah, I can save costs by, just having my own framer or whoever. You put up all the fern strips, and you just got to think about everything that goes with that. You get an all-in-one product. It's a lot less labor intensive, and it may pay off just by the quality of the tool.
This is one of those areas where redundancy matters. It's ideally you put up the weather barrier, and then your rain screen over that, and that's going to deal with the air leakage through the exterior wall, but probably not. It's so you build in a redundancy. So you're sealing the cavity from the inside of the wall. Hopefully that's going to deal with the air coming through there. Maybe it's not. So you seal the drywall. You seal all the penetrations through the drywall. So it's built in. It's every piece of the puzzle is what ultimately deals with the air coming through. Well, thank you all for your time. Thanks for being so kind. This was both of our first time presenting to a crowd like this. So thanks for throwing anything at us. Thanks for not having tomatoes to throw, Tony.
Well, thank you. So again, thank you, all of you, for coming. Obviously, there was a lot here. This was very high level. For those of you that want to learn more, which I encourage you to, because as Jacob said, this is not going away. It's only getting more involved, and expectations are going to only increase over time. We have a great local building show called Build Right coming up very shortly, put on by the HBA, and the Home Performance Council there tirelessly works every year to improve content, and it's everything that we've talked about here, from air management to performance, green building, anything you can imagine. They have segments there that go through that. And for those of you that have CCBs, it's a no-brainer, because you get all the credits that are offered are all CCB compliant. You get eight of your 16 needed 1 year. You go back the second year and you're not attending any other courses, and you're learning a ton of information. It's very well put on. It grows every single year, and I encourage you guys to go. For those of you in the labor side of things, siders, framers, construction instruction, it's got an app you can put on your phone. They have videos about every form of assembly and all best practices. And they have it in Spanish, they have it in English. They do workshops. They have a new facility in Colorado. I don't know if they still have the location in Scottsdale, but this is all available to us as a trade that we're not going to learn from our building inspectors, and we're not going to learn from our building officials. Jacob and I spent, I don't know how long, trying to get our City of Vancouver builder official to understand that there was a performance path to the new code. And he kept pushing back on our plans, going, you're not compliant, you're not compliant. And I said, we're going the performance path. He had no idea what we were talking about, and I had to involve Jacob. In fact, the, what was that form called, to the alternative?
Oh, you're talking the UA trade-off.
Yeah, so the UA trade-off form, he had never seen it. He didn't know, he had to talk with his management, and I had to agree to have him talk to Jacob just to move us off his hangups. He wanted prescriptive path, you don't have this, you don't comply. And I was like, we're way over compliant. And he couldn't wrap his brain around it. And for those of you that want a true deep dive, EEBA is probably, it's the best green building home performance show in the country. It moves around every year. This year it's in St. Paul. Last year I think it was in Salt Lake. It was here in Portland when I went. And if you want a true deep dive, that is the place to go. And anyone that is involved in this world is there, and they have hands-on workshops for basically every trade. And I recommend anyone that is going to be in this for the long haul to start just chipping away at learning, because the codes do not give us direction. They just give us points to check off. And hopefully today all of you can walk away with a little more of an understanding of how your component, how your assembly, how your installation affects the overall performance of the home, and realize you're actually a part of something bigger than you may already think you are. So again, thank you. It means a lot for Adrian and I that you guys took time out to come here today and learn about, what we do and why we do it. And any of you that would be interested in going to Build Right, send me a text or an email and I can send you the link to the HBA website. And I encourage you all to go. It's a great show, and it's literally right across the river. So thank you guys very much.